I think everybody missed a key issue on the last problem. We'll go over that, so don't worry about it right now until we get to it.
That means you give us credit, right?
Sorry, I had to clear my throat there. I wasn't laughing at you. I was laughing with you. Sean's here. Jared's here. Ryan's here. Yeah. And that was my.
They don't have the full names.
All right, so let's put that. Yeah. I don't know why. Okay, write the word regrade on top.
And I remember I was like, I think at the airport, and I was like, I text Julio, hey Julio. Before you know, I had a question too. Did he ever tell you that?
You know, he could have, but I'm not going to claim I'm going to remember that. You know?
Now you got my number.
I've got some kind of mental list in my head, and once I get below that mental list, things just fall off of it, you know? Gone.
24-hour memory.
Yeah. I mean, if I got 300 things I'm supposed to remember, and I get the 301st on there, and you're it, sorry. You know, bummer, dude. Yeah. All right. Okay. Let's go through this homework on chapter 5 that I just handed back. And then we'll do review on chapter 4, 5, and 6 on Monday, and have a test on Wednesday.
Next week.
Next week. For those who heard the intimations of that at the end of last class, you probably have following that. Some people will be out on Friday, and we can't wait another week. Okay, so chapter 5, homework problem 1, determine the chapter 5. Determine the demand load for a building that is used for machinery storage and has a workshop with the following loads. It's got what does it have in there? It's got 18 120 volt lighting and convenience. Now, on a test kind of situation, I have learned to write that out because I've had people look at one 18,120 volt system. It's a weird voltage. I've never seen that before anywhere, but I've seen that I mean, not necessarily that particular way, but I've seen that confusion come up when it's written that way. But again, watch very carefully how that goes. Now, what do we have on that for a lighting convenience load? What are the volt amp load for each duplex plug or convenience lighting load? What is that? 180
Watt. Volt amp.
Volt amps, thank you. Yeah. So that is 180 volt amps times 18. So we end up with a VA column right here, which is 3,240. And the second one was a 3.5 kW heater. Now, electric heaters are what kind of loads?
Electric heaters are the one on the left column. Yeah, none.
Yeah. Pardon?
Big.
Non-fixed? No, I'm looking for the type of electrical load so we can just go to write some sort of...
Without diversity?
Totally resistive. All the way back to that one.
Oh, yeah.
Totally resistive.
That was 2 weeks ago.
Yeah. I mean, all the others were good too. Yeah, we're getting there. I mean, yeah, we're covering it. So that's good. So that's 3.5 kW. In terms of watts or volt amps, what is that? 3,500, thank you. That is another common error. Is that messed up with a decimal point on there. Please don't do that. Okay? And then a 1 horsepower automatic compressor. Okay, now, there's different ways of doing things on here. When you're looking at demand loads on things, I've been known to put the 25% extra load on the largest motor. Also, you can put just the numbers that are in the back of the book in appendix, I can't remember which table it's in, but a 1 horsepower motor at 240, and they actually have 230 volts on there. Why? Because by the time it gets to the motor, you probably have a little bit of a voltage drop, so that gives you a little bit of protection on the current, but you can end up with 1920 volt amps, and then I added 25% on that. Either number would be correct on here, either the 1920 or the 2400. Follows the old joke about, I know I'm paranoid, but am I paranoid enough? And then we have a 60 amp welder. 60 amp welder times 240 volts is 14,400 volts. So I add all this thing up, I get 23,540, or 480 less than that, which would be 23,060. So either one, would be okay. Now, load without diversity. Okay, that's just adding everything up. What do we do with lighting and convenience load? Half that. Okay, so we got half of that, so that's 1620. Now, what about all the rest of this? They gave you a funky word there about the compressor. What did they tell you about the compressor? It was automatic. Yeah, we're working through this homework, Freddie, and most everybody got something wrong in the last problem, so we're going to go through some of the homework. So about these 3 loads here, what about all 3 of those? I got a heater, I got an automatic air compressor, and a welder. What are the odds on all 3 of those coming on at the same time?
Pretty high.
Yeah. Well, the thing is, if I'm in the winter and I'm in the shop and I use the welder, you have to take into account that both of those things could come on. The key issue is it's an automatic compressor. It's not one of those small tanks you can hold around and just plug in the wall and you can unplug it. It's a fixed, in-place shop air compressor. Okay, so then, just like in our shop, it can come on anytime. So once you do that, you have to take into account all of these. So I've got 3,500, 2,400, and 14,400. So I got 1620 less than that, so I end up with 21,920. Now, what do I do next on this thing? Well, convert it to the amps. So I divide through each one by 240 volts. So what do I get? 98.08. Now again, if you put 1920 in there, that'd be slightly different. And over here I get 91.33. Now what's next? Yeah.
Hold on. I use 1920, but I can't figure out where I got 1920 from. Is that something fancy?
Yeah. You've got a 1 horsepower, and they give you, what's the amperage for a 1 horsepower?
I'm looking at them.
1.25.
Yeah, good.
1920 we have about 1.25.
Yeah, right.
Oh, there's 125%
Yeah.
of it.
Single phase, they don't tell you it's 3 phase, right? So we're assuming small motors less than 20 horsepower are single phase. So the 1 horsepower is 8 amps at 230 volts. So 8 amps times 240 gives you 1,600, and 320 is 1920.
Okay.
Yeah. And if I do 1.25, that gives me 2,400. Okay, good question. Where did that number come from? The 1920 or the 240? If you go back into, which table was that?
The table 8.3.
8.3, yeah. 8.3, that's for single phase. You have to have some knowledge about whether it's single phase or three phase. What is a good rule of thumb on that? Anything less than 20 horsepower could possibly be single phase. Anything greater than 20 horsepower, unless you have a real specialty market, is three phase. That's the problem we have in our rural areas. They'll bring 220 lines, 240 lines down to the ranches, and that pretty much fixes you in place with 20 horsepower. If you're down there doing some grain drying, what are the big manufacturers doing with grain dryers these days? They're all 50 horsepower. They're for big organizations. So if you want to do grain drying, you're stuck with finding something at an old farm estate sale that's energy inefficient and 40 years old, 30 years old, 20 years old. So a little bit of a rub there. So, single phase, and it gives you, for a 1 horsepower motor, gives you 8 amps. Now, 8 amps times 240 gives me 1920 volt amps, which is what I did right there. I multiplied it times 1.25. You don't always have to do that. You know, it's the largest motor in the place, so I kind of looked at it that way. So now I've got this situation here. How do I figure the demand load up for the building? Well, it tells you, first of all, take a look at the largest up. The largest up. Okay? Which one's the first one? Load without diversity. Okay, so that's 91.33 LWD, 91.33 amps. Okay, the next one is the largest motor times that 25%, or adding the 25%. So that's 2,400 volt amps. 2,400 volt amps divided by 240 gives me 10 amps. So largest motor, 10 amps. Okay, the last category is smallest to an ag building is 60 amps, right? So minimum ag building is 60 amps. Okay, which one's the biggest of those? First one. So I start off with 91.33 amps. Now, next thing is I take 50% of the next chunk, okay, which is 0.5 times 98.08 minus 91.33. And that gives me a grand total of, that number is about 3.4, approximately equal to 3.4 amps. I add it onto that, and I end up with 94.73. So demand load is equal to 91.33 plus 3.4 equal to 94.773 or 95 amps. You'll get slightly different numbers depending on whether you put 1920 here or 2400. That's the process. That's what you're looking through. You can complicate it any way you want. Where does the judgment come in? Where do you have to look at things and think about it rather than just doing something by memory, by rote? You got to figure out some logic. And you have to put some thought into how you're going to operate things. There's one problem where you have grain dryers. So you have a building that supports 4 grain dryers, and then it's got some other stuff in the building like a welder and an air compressor. Now, some of you will say, well, you're never going to operate 4 grain dryers, so, you know, I can have some judgment call on that. Well, yeah, you are. When are you going to operate 4 grain dryers? Harvest. Yeah. When you harvest everything, you're going to dry it all at once. Yeah. Either that or you're going to get mold. Exactly. So I dry them all at once, and something breaks. They're all going donuts to donuts, and something